Hello, Spark fans, and welcome back to Advancing Spark, where today we're taking a little bit of a walk on the easy side with an introduction to how Hive works and some of the functions and ways that I normally work with Hive. Now, I've been looking into the Photon engine and SQL Analytics on one side and Azure Purview on the other side, and Hive is really central to the ways that we work with both. Now, I keep coming across people who don't use Hive, and they're like, yeah, it's okay, but we don't really use it, right? Or I guess they find it really manual. So I just want to kind of take a real quick look today at some of the introductory stuff about how we work with Hive, how you can automate Hive, how you can use some of the tips and tricks to kind of make your life a lot easier when you're getting started with Hive. So if you're already a Hive expert, skip to the next video, you'll be fine. But if you don't get the most out of Hive, if you don't find yourself being able to automatically loop through every table that you have, being able to automatically register a table with Hive with ease, might want to watch. If you're new to the channel, as always, do not forget to like and subscribe. If you have any other things that you want us to try and cover at some point, let us know down in the comments. Otherwise, let's have a look. Okay, so I have Databricks open here. Now, the first thing, if you're not used to using Hive that much, if you've got a cluster turned on, you've got this data tab, and that's basically what's in my Hive metastore. What's going on? Well, that doesn't know. So we can have a look across all the different tables that I've got registered, and I just see my list of tables. And for me, that's the anchor point. That's the thing that grounds anyone coming from a relational database background, anyone coming from any other kind of data store. Opening Databricks can be intimidating because you get a blank slate. You get nothing. You get a cluster that you can hook up to lakes, and you have to traverse the file folders, know where to look for your data. But the moment you start listing databases and tables, people go, okay, know what I'm doing here. I can find my stuff. So using Hive, this is all of your Hive metastore. These are all your different Hive databases that you have, each of which has a Hive table in there. And obviously we have things like we can click on it, we can get the schema, we can get a sample bit of data, and we can start to understand what's going on in there a bit more. So Hive, super useful. And especially if you're going to hook up Power BI or Tableau or Click or any other kind of external tool, or if you're going to use SQL Analytics, it relies on Hive. It relies on having this in place to be able to use it. So Hive is this mechanism for creating virtual databases and tables on top of your data. Now, don't get me wrong, you can actually store your data physically in these tables, but it's not really the best way to do it. So there's the whole save as table function. Avoid that like the plague if you are keeping in a separate external data lake. So we never really use that, which means we have to use SQL to register our tables. We have to write a SQL command saying, look after this table, it's over there in the lake, but make it appear in my database. And we'll step through some of the basics of that. Okay, so I've got a notebook here, it's running on a cluster. And I can do things like this. I can say, well, show me all of my tables. And that is like a super useful little function, right? And we'll get onto some of the more stuff we can do with that. And a lot of people don't know you can actually do that. So they just go show tables and it gives them their default database. And it's like, well, that's not that useful. So show tables from database gives you that nice little list for the specific database you're looking at. And you get that rough idea of what's going on. Okay, basics. Creating things. So we've got, create database if not exists. What do you want it called? And then if I've done that, so new DB should now be living over. I've got new DB. I've got no tables in it. So that mechanism for creating these logical databases, these basically just containers where I put these pointers to things in my lake, super simple. Create them, delete them, whatever you want. It's nice and easy. Then actually creating a table. So I've got something here. Let me, do I have my lake somewhere? I'm going to bring in what I'm looking at in my lake. I just bring that into context. So I've got a lake here, my DB lake. I've got my root folder. Loads and loads of stuff in there. So I've got my base folder. I've got so much stuff. Got my folders. What am I looking at? So I'm looking at Public Adventure Works, Delta. And then inside there, that's a Delta table. I can see I've got my Delta log. I've got some Parquet files. So that is a Delta table I want to register. So I've got my path to where that lives. And I know it's of a format Delta. So I can do that. Create table. If not exists, again, that's optional. I don't need to have the if not exists, but I like it to not throw me an error if the table's already there. New db.mytable. If I hadn't already created that database, I would get an error saying that database doesn't exist. What are you trying to do? I need to tell it what format it is. So Hive tables can be CSV, it can be text, it can be Parquet, it can be Delta, it can be JSON. You can just have this whole load of different file formats, and it will just kind of expose them all as just SQL tables. So it's a way to abstract away from what's going on under the hood. What formats am I dealing with? So you can have a database with 100 tables in it, some of which are CSV, some of which are Parquet, some of which are Delta, and the user doesn't care. They can just go in there and go select star from table and do whatever they want, and you're abstracting away from the problem of file storage. That's super, super important if you're managing this curated layer to say, I want to make it really easy for my business users. If you've got this kind of solid Hive layer that just standardizes everything, even though it's not standardized under the hood, cool, which makes life a lot easier. So in this case, it's a Delta table. So I'm saying using Delta as the format. So Hive knows how to understand and how to query that particular file. And then location, and I'm going to get a location. Now, if I didn't have that, if I didn't have the location, it would assume I want this to be created inside Database's own file storage, inside DBFS. So I can create a table without a location, and it stores the data somewhere. It basically creates a blank container saying, sure, I'll let you just insert data into this other place. If I give it a location, everything that happens where I can see it. It happens in my lake. So in this case, because this table already exists, then I can give it a location and it'll read the schema from there. So I'm not set a list of columns. I'm not giving it a list of anything. This is assuming I've already done something to create my data to land it in my lake. Then I can just run this command. Say, register. This is essentially not doing any data manipulation. I'm just picking that data up and saying, newdb.mytable needs to represent this place in the lake. So you can see in newdb, I've now got my table, and it's got the schema registered. It's got sample data. It's not actually done anything with that data behind the scenes, but it actually has understood it and it's registered it with Hive. So now anytime someone coming in and using my workspace, they can write this SQL. Say, select star from newdb.mytable. I turn it off for case. There we go. I've got some data. And that just enables all of the analytics, all of those other tools pointing in, all of those interesting things coming in and playing with it. It's just been enabled because I've done some stuff with Hive. Okay. So basically making sure you have that mechanism anytime you're doing engineering, anytime you're kind of programmatically manipulating, transforming, cleaning, curating data. I kind of want to be putting it in Hive. I kind of want to be forcing it to say, you should actually expose this into my Hive metastore. Even if I've got several layers in my lake, if I'm doing kind of the medallion architecture zoning, if I'm doing my raw base enriched, if I'm doing my stage clean warehouse, whatever layers that you have, I kind of want to expose that as well. So I can have people looking at the intermediary layer, my kind of ODS style layer, have them looking at the warehouse layer. And you can just do interesting stuff by using Hive that way. So, very, very good. And you might ask why I'm using percentage SQL. I'm going to get onto that. Okay, we can drop that. We can click that. Go away and delete those things. Interestingly, if we do it the other way around, if we create a table that not exists, okay, doesn't have a new database, so let's create that database. Let's register that table again. If we just try and do the drop database, it's going to tell me off. It's going to say, that database has things in. The database is not empty. You can't do that. There's actually another command you can use, cascade. And that's like, drop that database and everything inside it, a cascading delete. So, a couple of useful things, just creating things, deleting things, having a play around. Now, that's okay. It's kind of useful, kind of does some stuff. And then I think this bit is when it starts to get interesting for me. So if we've got something like this, we've got I want to show tables from AdventureWorks. We had a look at that earlier. That gives me a data frame, which is just my list of all my things. But I can actually use that inside some PySpark. So I can say on a new data frame, that's the result of spark.sql show tables from AdventureWorks. And if I have a look at that, it's the same thing we saw earlier. So saying that kind of top one, that show tables as AdventureWorks, that is exactly the same as doing that spark.sql show tables from AdventureWorks. Okay, that's kind of nice. That kind of does some stuff. But because we can get it inside a data frame, means we can do some interesting things. So I'm just going to do for a table in my data frame. I'm going to collect it. Now, collect is very dangerous. Collect is basically saying this data frame that is spread out across all my workers, that's using all the Spark engine and parallelism, I want you to collect it all up and give it to my driver. So if you're doing that on a large data set, that's going to be really bad. It's giving out memory issues. Be very careful about how often you're using collect and how much data you're sending. In this case, it's metadata. We're dealing with 10, 20, worst case, a couple of thousand rows. It's not really the kind of thing that's going to tank your driver. If you're doing lots and lots of things in parallel that we're using that, be careful. But in this case, it's fine. Okay, so we've got that. And then because I'm doing that collect, that makes an iterable list. So I can say, well, actually, I can query these things. The database table name is temporary. So I can say, well, database. I can just print that out. It's going to give me a list of AdventureWorks lots of times. Say table name. And I get my list of tables. So because I've now got this thing from Hive, using show tables in Hive to bring me back my list, because I can use that as a data frame, I can start doing some really interesting stuff. I can say, well, actually, I want to make that an F string. Let's just make that a thing that's coming back. And I want you to attach in the database name. So let's go table.database name, put a dot in the middle, and then I've suddenly got, I can build things up, meaning I can do things like, select star from, and start getting it to generate some SQL for me. That's one thing. I can do that. That's nice and easy. I can also do more interesting stuff. So I can say, well, actually, if this is going to be my table name, or what do I want to call that? Okay, I'll call it a full table. And get rid of that bit. I'm actually going to store that. I should combine those two things and say, well, my full table name is going to call that. And then I want to have a little data frame down here. So my new data frame is equal to spark.sql. And then I want to take that full table. Use that. So when you've got spark.sql, that's expecting you to give it a string that it then interprets as a full SQL statement, something it can run entirely within SQL. If you spark.table, it's basically just doing a select star from whatever you give it as a table object. So if that can find a view or if it can find a table inside your Hive metastore, it just brings that back as a data frame. So I'm saying inside this one, for each loop I'm doing, I want to spin up a new data frame and then bring in the contents of whatever that Hive table is. So I can then say print. I can do another F string saying so table, and then I want my full table has, and then I want my, let's do a count. So new df.count. So I'm saying there's a variable called count, which has got the count from that current one. I want to put that in there. Rows. Okay, lots of things going on there. So I'm working out the table name just by stitching the two things together. So I'm getting a variable, which is essentially that AdventureWorks.address, product, country, etc. I'm then saying on a new data frame, just a select star from that current table I'm on. I'm saying I want to do a count of that table and store it as a variable. And then building up a string saying table, its name has that many rows. See how that goes. Yeah. So it runs through, and you can see it does do a Spark job for each of those loops. It's going off and doing some work. So doing this kind of thing, you can very easily suddenly spin off Spark into doing way more work than you're intending to. But if we're doing some super quick row validation, if maybe we could be spitting this out into another array or into an audit data frame or into my logging database, suddenly your ability to say, give me a full list of tables as an iteratable object, and you can suddenly do lots and lots of things. So really interesting, useful stuff you can do if you're aware of things like show tables, and if you're registering your tables in Hive. Suddenly auditing your lake becomes super useful. And again, having delta and having additional operational metrics and all that kind of stuff just makes that even more powerful. So just use Hive, please. Okay, so that's one thing. You can see I've played around doing it earlier. What about if you want to have something at the end of my workflow? If I'm doing a load of PySpark, I'm doing a load of processing, and I want to build out a function. I want to actually just remember to register Hive. I don't have to write some SQL every time and hard code it. Hard coding SQL is the opposite of all the frameworking that we do. That's why I always have something like this, something along these lines. Like, so I can define a function. So I'm saying I want to make a Python function. I want to accept a load of parameters. So the database name, table name, the file format, the file path. So all of the components of our bit up here, all of our components of our create table script that are going to be different each time. So the database name is going to be different each time. The table name, the file format could be different each time. And this location. I'm essentially saying, well, create a function that can pass all those elements in. I've got an additional debug, so I can choose, do I want to just print out what it's going to do, or do I want to actually see the code? And then it's as simple as that. So create database if none exists, and then I'm injecting the parameter. And I'm storing that as a bit of a string. And then I can just do spark.sql and run that string. So that combination, that kind of intersection of when you can run SQL through PySpark means you can have dynamic SQL and generate up these strings, run that as spark.sql, and then it'll go and execute that for me. So the first bit of the function is saying, if the database doesn't exist, just create it. And if I'm debugging, print it out so I can actually see what it does. If I'm not debugging, go ahead and run that script. Now, once I've done that, once I've got my database in place, I can do the same with the table. So create table if none exists, take the database name, take the table name, bring them together, put in the file format, Delta, CSV, JSON, etc., and then put in the file path. And it just builds out that particular string. And having something like that as part of your engineering process, as part of all the different scripts you're doing, that at the end of it land a data frame of data somewhere. If it can fit inside a data frame and you can express it as a data frame, you can likely register it with Hive. There's one or two limitations in terms of what the column names can be called with special characters and that kind of stuff, but otherwise you can probably get it into Hive. So at the end of that, once you've got that done, so I'm just populating those variables. So I've got my new DB, my table, delta, file path, debug, calling that function. So I'm going to run that, make sure that function's registered. Okay. And then passing it in, I've got debug set to 1. So because of that, it's going to send it to print, not to Spark SQL. I should actually just see, there we go. That just generates the same SQL I was going to use earlier, except it's obviously done it programmatically for me. So just at the end of everything that you're doing, whenever you land something in your lake, go, I want to go and register that. So I'm not going to be happy because the table already exists. Yeah. Trying to grade it. Doesn't like it. Oh no. Ooh, no, because I gave it the wrong location. And this will tell me off. There we go. So having those processes so whenever someone finishes doing something, you've got that database name, you've got your table in there, and that's suddenly so available and so accessible to users is pretty cool. Now, the thing I'll be looking at in the next few videos is, so how do we use Photo on top of that? So now that we've got that registered, now that we can see that in SQL Analytics, now that we've got that foundational bedrock of our entire data model, which could be split over different lakes. I could have very secure, separated lakes and expose that as a single set of Hive metastores. Or I can have all them all as different databases and have different security contexts across it. All super important at then getting to the bottom of how this all fits together. So we'll have a look at Purview. So I want to be able to see, how do we actually get a Hive table into Purview? Can we do it yet, or is that coming? How do we manually register it via the API? There's a lot of stuff in there. And that Hive metastore is so core. It's basically the handoff between people who are working at the lake level and people who are working in BI tools. And if we can get that middle bit bridged via tools like Purview, then suddenly everything makes a lot more sense. Okay, so again, apologies if you've been using Spark for years and that is teaching you to suck eggs, but hopefully you learned something. Hopefully you got a few ideas about, I didn't realize you could iterate that. I didn't realize you could pull that out. Hopefully you learned something. And as always, don't forget to like and subscribe. Let us know down in the comments if there's any other introductory elements you want us to go through. But otherwise, I'll be using this, digging further into it as we explore both Photon and Preview in the next few videos. Take care.